For this example, right, it's an extension of cubic equation. So if you look at part A, 4A, example 4A, you realize that it's the normal factorization of your cubic equation. So you just do your normal step. Okay, you do your own trial and error to find a factor. Okay, do something to find you punch calculator to find a factor, and then followed by long division. Ensure that your long division will end up with a remainder 0. So in this case, right, if I'm not showing you the long division, I'm just going to write the answer here. So in this case, at the end of your long division, you should be able to factorize properly. So that is like your typical method for your cubic equation. So nothing changes. So you follow the instruction. If the instruction is for you to factorize, you factorize. If the instruction is for you to solve, you go ahead and solve. Okay, the challenge part will be the hand. Okay, the challenge part will be hand. You realize that there is a hand or otherwise. So hands means I must be using the factorized answer. The otherwise, right, will be you can choose to expand out. Of course, it's not very advisable because it's going to be very long expansion. Okay, so you are advised to relate back to part A. So if you observe this expression, okay, maybe to make things simple, I'm just going to put my original fx here. Okay. I'm going to write it here. So if you put your original fx here, you realize that this looks somewhat similar. It looks like the 3x cube and the 3 bracket y minus 1 cube looks somewhat similar. So same for this. Until here, it doesn't become. The last part has a slight difference, especially the constant. So fx has a constant of -2, whereas this expression has a constant of -11. But if you do a little bit of guessing, you should be able to guess that the x is changed. The x has been changed to y minus 1. So if you do an initial inspection, you should have this instinct first. So how you verify the instinct? I'm going to do some manipulation. I'm going to do the manipulation on the last part. I'm going to break the 11. The -11, I'm going to break it to -9 minus 2. So I break the -11 to -9 minus 2. Okay, reason being, if I do this, I can factorize. Then, if let's say right now I compare with the original as fx, you realize that your guess of x being changed to y minus 1 is true. So if you do the comparison, you should be able to see that x has been changed. So essentially, when you do such a comparison and you realize that this is the relationship, so it means that the original x has been changed to y minus 1. So this whole thing is behaving like y minus 1. Okay, you can see it that way, or you can directly just change the x into your factorized answer. So the x will have been changed. Instead of x minus 1, I got y minus 1 minus 1. Instead of 3x minus 1, okay, I got 3 bracket y minus 1 minus 1. So I got a y minus 1 minus 2. So I make use of the already factorized answer. And from here, this will be 1 bracket. And from here, this will be another bracket. And from here, you simplify, there will be another bracket. Because I use the previous answer, I go through a shorter way of factorizing. So eventually, I still get the 3 brackets, which allow me to solve. Okay, so in this example, it's a very simple one. This one is a very obvious one where x is being changed to 1 minus 1. There are some questions where x can be changed to logarithm, or x can be changed to trigo, or x can be changed to indices. Okay, so of course, x can be changed to some other algebra as well. Okay, so this is the more direct one. There's quite a few examples that it will be in the consolidation set where you actually try this idea. Okay, then subsequently, example 5 is another consolidation polynomial question. It is kind of working backwards. Okay, so this one, right, a lot of students, right, couldn't get started, couldn't get this question started. Partly couldn't work backwards. Okay, or partly they didn't know that these roots are x. So they didn't know that these 3 values are x. Okay, so let's try to rephrase the question. So what the question is trying to tell you is when fx is equal to 0, you end up having x equal to 1, you end up x equal to 2, you also end up x equal to k. That is the meaning of the roots. So you get 3 roots. So it's a bit like the answer here. I got 3 values of y. So if you look carefully, the values of y actually come from some brackets. So I'm going to use this idea. I'm going to shuffle it back. So when I shuffle it back, I get x minus 1 equal to 0. I get x minus 2 equal to 0. I get x minus k equal to 0. So the 3 items here will be the brackets that originally belong to fx. So that's how I formulate my fx. So you formulate the 3 brackets with the 3 roots. Okay, but you do need to factor in the coefficient. So you got to factor in the coefficient. If they say that the coefficient of x cubed is 2, then you just put a 2 outside the 3 bracket. Okay, and then please double check that you really get a minus x cubed. Okay, so one of the common mistake will be some students, they forgot to factor in the coefficient of x cubed. After you factor in, so you can simplify this into a 1 minus x, x minus 2, x minus k. So this will be the expression for fx. Okay, after that, sometimes students will focus on expand out these 3 brackets. If the question never asks you to expand out, then please keep the fx in this way. Do not spend the extra time to go and expand out the 3 brackets. And you waste time and expose yourself to careless mistake. If the question would like you to expand, they will say that express fx in descending order of x, meaning x cubed, x2, x squared, and x and constant. So in this case, I'm going to do my remainder theorem. So from the information, I know that f3 will be equal to 8. So how do you execute f3? That means all the x has been changed to 3. And the remainder is going to be 8. So you can just insert the x into the bracket. In fact, right, you can just punch calculator. So I managed to use my remainder theorem, but I didn't expand out my fx. It's not a necessity to expand out in this case because the question never asked for it. Finally, when I gotten my k, put the k back into the expression, and still I'm not going to expand out. So right now I will need to find another remainder. So that will be a f minus 3. So you sub inside, and then you punch calculator. So you will get a 4 minus 5 minus 10. So the remainder will be 200. Okay, so there's a variety of this type of question that you will see because it appears for O-level question. So it's a work backwards from the roots to formulate your fx, but do bear in mind the coefficient of x cubed. They will have to give you the coefficient of x cubed. Okay, so these are the 2 sample example of end of this topic. Okay, so later on in the consolidation set, you will find similar question on this.